This is TechCrunch. Manufacturing has been one of the hottest categories in venture this year, but there are still many innovative materials and processes yet to scale. One example is thermoset composites, materials widely used in aerospace and defense due to their high heat resistance and lightweight, but which typically have long lead times and high prices for customers. Raven Space Systems, a startup based in Kansas City, Missouri, says it has developed a new process to enable the first scalable 3D printing of commercial, off-the-shelf thermoset composite components. We're essentially unlocking an entire field of 3D printing to production scale, Raven co-founder and CEO Blake Herron said in a recent interview. We're taking these off-the-shelf materials that have been proven for both structures and thermal protection applications and automating the near-net shape production by 3D printing them for the first time. Raven is able to do this using a technology they've patented called microwave-assisted deposition, MAD 3D printing. Usually thermoset composites require hours or even days in an oven to harden or cure, but the MAD process essentially cures the materials during the printing process, a bit like laser-based metal additive printing. Herron and his co-founder Ryan Caudry started working on the technology while grad students at the University of Oklahoma. Around the time they graduated, they landed about $1 million in grants through the Small Business Innovation and Research Program to take the MAD 3D printing concept from whiteboard to prototype. Since 2020, Raven has scored around $4.5 million of non-dilutive contracts from the Air Force, NASA, the National Science Foundation, and other awards. To take the technology to the next level, the startup also just closed a $2 million pre-seed round led by Backswing Ventures, with participation from 46 Venture Capital, Mana Ventures, What If Ventures, and Cape Fear Ventures. The new capital will go toward the company's first full-scale manufacturing lines, production-scale 3D printers, mixing systems, and machining. By the second quarter of next year, Raven aims to move out of its 3,000-square-foot facility and into a larger factory certified for aerospace production. There, they'll start manufacturing components for customers, starting with smaller components and scaling up from there. Raven's go-to-market strategy is to provide thermal protection components for solid rocket motors and hypersonic vessels initially, because that's where the two co-founders saw demand from the Department of Defense, Herron said. "We're not the world superpower we once were," he said. "There's a massive need there, supply chain, bottleneck issues. Everybody has a hair-on-fire problem with these thermal protection and structured materials. In these industries, there are not enough suppliers," he said. Of the suppliers that do exist, many work in outdated factories using methods dating back decades. Herron said scaling the new 3D printing process will go hand in hand with building a next-gen factory in order to reduce lead times to days instead of several months or over a year. "I think the industrial base requires implementing software and robotics into our factories to solve these supply chain issues and, frankly, compete globally," he said. Beyond hypersonics and rockets, the company has also had conversations with autonomous systems providers, satellite manufacturers, and space propulsion companies. Earlier this week, the company announced it was partnering with re-entry capsule developer SpaceWorks to develop 3D printed re-entry vehicle aeroshells, the structure that encapsulates the spacecraft and provides the thermal protection to enable the DoD to test hypersonic tech. The tech is still early in that there are still tech challenges involved with scaling it to print larger structures, Herron admits, but once it's fully developed, I see this as changing the way we make large-scale composites. It's going to take some capital and time to scale up to the very large systems that this can be used for, but right now, it's simple, small parts using designs that are delivered by customers and solving the supply chain issues by really developing the most efficient production lines that we can.